So here is lesson 2 continued. We're doing compound interest now. It is dealing with real life situations like savings accounts or population increases. All right, so we're given our compound interest formula. A equals P times the quantity 1 plus R divided by K to the K times T power. All right, so let's explain what all these things are. First of all, amount is the final amount. So whatever your answer is, that's what it's going to be. For P, it's called the principal. This is also called the initial amount, whatever you're starting with. R is the rate, usually given as a percentage. All right. K is the tricky one. It's the number of compounding periods. Okay, so what that means is usually when you do compound interest or population rate growth, right, you have everything in terms of a year, but you can also have it broken down into other sections of a year. You could do months, you could do weeks, you could do days. Depending on what you're doing, that's what that K value is going to be. And we'll see some examples of that in a minute. And then finally, T is the time in years. Okay, so those are all the pieces of our compounding interest. So now let's try to use them. So we have Carolyn opens her first savings account by depositing $500 in a bank that offers a 6% interest rate. So here we go. So we use the formula. So we have A of T equals her initial principal, which is $500. 1 is part of the formula, plus the rate of 6%. So you're going to change 6% into a decimal. So it's going to be 0.06. All right, since it says once per year, our K value is 1. All right, and then we have K again, 1 times 1, or well, we're not given how many years it is, it's just T years. Okay, so there's your formula. So now, as always with math, if you have just ones, you don't really need to write those, like the ones that are being divided with the 0.06 or the 1 times T. You don't need them, but we're going to put them in there just so you can see where they're at. Okay, now number 4, we're going to actually figure out what it is after 1 year. So we have A of T equals 500. All right, and then 1 plus, since we don't need them, I'm not going to write them out right now, 0.06. And then for 1 year, K is 1, T is 1, so it's just going to be 1. So to figure this out, we're going to go to our calculator. So we have 500. All right, times 1 plus 0.06, close the parentheses, to the first power. That's going to give us $530. So we go back here. I don't know what that is. There we go. So we're going to get $530. There's our answer. Okay, number 5, same idea, but this time we're going to do 5 years. Okay, since we're doing yearly again, the K value is still 1. So we have A of T equals 500. 1 plus 0.06. And this time the T value is 5. 5 as our years. All right, again, we can go to our calculator. We have 500. 1 plus 0.06 raised to the 5th power. So we got 669.11. So we have 669.11. There we go. All right, now number 6 is where that compounding interest periods come in, okay? So now it says if the interest, so it says calculate the amount of money Carolyn will have in her savings at the end of the year if interest is compounded monthly. Okay, so we're going to write the same thing as before, but this time our K value is going to change from 1 to something else. So we have 1 plus 0.06. Now monthly, we want to figure out how many months in a year. That would be 12. Okay, now K would be 12. and our t value is going to be 1. Oops. Here we go. Perfect. Okay, so now we're going to have to put this in to the calculator to find out what it's going to be after a year if the interest is compounded monthly. So we go back to our calculator. 500, 1 plus 0.06 divided by 12 raised to the 12 power. Okay, so although it's a year, the k value is 12, and k times 1 would be 12. So now we have $530.84, we'll round up. Okay, so notice this one's a lot, well, not a lot. It's 84 cents more than if it was just compounded at the end of the year versus by every month. Okay, eventually that would grow to very big amount. That 84 cents, because you're compounding so often, it would grow faster than the compounding for just 1 year. All right, we can see that again in number 7. Okay, so again, we're going to do the same thing as we did in number 6, but this time we're going to do it by weekly. So weekly, if you don't know how many weeks are in a year, all right, we look down here. Weekly would be 52. Okay, so we have A of t equals 500. 1 plus 0.06. I'm going to make that a better fraction. 0.06 divided by 52. And then 52 would be the k value, and the year is still 1, so that's going to be our equation. All right. Again, we go back to our calculator. We have 500. 1 plus 0.06 divided by 52 raised to the 52 power. Okay, so 530.9. We're going to round up. So $530.90. So at first it'll be small differences, but the further you went on, they would become more and more. Okay, so the more you compound, all right, the better off you're going to be. Now eventually you can compound so much that it just becomes a straight number. That's what we're going to see here. Okay, so if you notice, we have quarterly, which is 4, we have monthly, which is 12, weekly is 52, and so on and so forth. When you start getting to be really big numbers, you'll start to see these numbers right here all start to kind of be the same. Okay, and what we have is if it's compounding continuously, like all the time, all right, it's going to be close enough to a specific number called e. Now, e is a lot like pi, where pi has a specific number value associated with it as a symbol that represents a number. E is the same way. E, as you can see here, is this big number. Okay. Now, that is in your calculator already. It's stored as a number. You don't have to like memorize it or remember it's 2.71 even. Okay. We can just use it as it is when we get to that. All right. All right. So let's